Welcome to the Fraunhofer Digital Media Weekly Specials. I'm Janet Greco from Broadcast Projects, and today I'm pleased to welcome Hanna Lukashevich. Hanna is Fraunhofer IDMT's head of Semantic Music Technologies, which is famous for its work in the audio domain. Today we're going to learn more about Hanna's work at the Fraunhofer Institute of Digital Media Technology. Welcome, Hanna.
Thank you, Janet. Yeah, that's true. Audio is our specialty. We work on audio for over 20 years. You may know our work on audio fingerprinting that we started 2000, many years ago, long before it was common to recognize music or ads automatically. So for my work, it's especially focused on solving the problems, complex problems for professional media producers, music producers, audiovisual producers, all that involves music in the production.
Okay, and what kind of work are you doing for them? So how are you helping them exactly?
Yeah, so usually the problems we are having are quite complex ones. That music plays an important role in the production. And with our technologies, we can localize precise audio recording, precise clip or sound. We can find the sounds or music sounds that are matching a particular mood of the video, to give an example.
Okay, so this sounds like a lot of data being crunched here.
Yeah, sure. So we need to combine a great amount of many sources. Of course, the audio work is music, but quite often also videos, still images, text, and of course also a lot of metadata that is combined to those data. And what we do then we use signal processing, AR and meshing technologies, and the combination of all that, of course, is that what we refer to as multimodal approach.
And I guess that's very effective for solving complex problems that music producers could face and other types of audiovisual producers. So what kind of audio solutions can you bring? Can you give us some examples of the use cases for this kind of technology?
So these technologies are the most efficient when it comes to the bigger amount of information. And then the common big issue is indexing large amounts of content. For instance, in a music library, on archive, or of a TV and radio station. When there are a lot of data, then basically there is no time to manually sift through all that data, and you need smart tools to be able to find information you want. Mm-hmm. The professional producers, they need fast access to many music options. And to do this, they depend on specialists and on search engines. So basically, what we can do is enhance how these work, and that is where our R&D expertise come into place.
Mm-hmm. Okay, so you're developing tools for music and audio producers, and you're doing R&D work. Can you tell us a little bit more about the R&D work that you're engaged at the Institute?
Mm-hmm. Sure. Their R&D work, it's customized. Every time customers are to a particular use case. So we start with consulting advice, we analyze situation, we analyze the use case, and from that what we have, we search for so-called building blocks, components, or signal processing AI components which can enhance the performance of the software of our customers and more fully automate the search process.
So as I understand it, what you're doing for these producers is being able to give them sort of compartmentalized building blocks, components, as you call them, that they can basically design a solution that's very bespoke for them, that they don't have to try and go off the shelf and buy something that maybe doesn't completely fit your needs. Your solutions are more customized in that sense. So where does this concept of semantic music come into play here? What are the use cases for that? And is it part of the whole R&D work that you're doing from a components perspective?
Yeah, so maybe let me bring you an example. For instance, you are doing a video production. And of course, for your video production, you need music. And it's quite usual in the beginning of the video production to work with so-called placeholders, the known music that everyone knows, but you don't want to have exactly particular that music piece in your final video production. For instance, because maybe the rights of that music piece are not appropriate for the video production you want to do. And then imagine you have a multiple components that can analyze music according to genre, mood, instrumentation, vocals that are in place, and can help you to find music that is quite similar or maybe different in particular options, and that can be used in your video production. So that's the way how that magic of different components come to the place. And then it can help you to find a sound that is just perfect for the video production, and that gives you the right feeling for the right video.
So here you're speeding very much up the process to find just the right sound, and presumably you're using AI very heavily in terms of the work that you're doing.
Yeah, right. And for that, of course, we have our own magic or tool set of signal processing and, of course, AI in combination with signal processing. And then you can imagine music as a set of attributes associated to that music with rhythm, tempo, harmonies, instruments, vocals, and so on. And with signal processing and AI, and of course, with domain knowledge of the music, we can, create models based on signal processing that are able to train particular properties of the music. And once trained, this model can be applied to unseen data and infer that knowledge back out of the model. To give an example, for instance, if you're interested in music instruments, you can train a model that can identify and recognize music instruments. And then you can apply that model to new data and it generates you the tags for different instrumentations.
Very interesting. So that's super useful for the search engines for sounds that is needed by all of these different players. So how accurate can these results be? And how long do you have to keep training the model? Is it something that you have to keep doing, or is it done once and it's done? How does that work?
Mm-hmm. I mean, of course, sometimes it just once done, and if it's working good enough, then never touch a running system. But I mean, the rule of thumb is that, of course, the longer you train, the more the model adapts to your use case. The longer you train, the better it gets. And there are some simple problems that are nearly solved. For instance, if you just need a music detector, it works already now with something like 99% of accuracy for clear music signals, and a bit lower, maybe 80-something, for detection of really, really volume background music. Mm-hmm. And all those components, of course, you can apply them online and offline and to live streaming environments. So all is possible.
Wow. So all this stuff that you're doing, I guess this also applies very much to radio and TV broadcasters just as well as for music producers. I guess you're here adapting the same approach to different tasks?
Yeah, right. So that multi-model approach and our set of components is quite a flexible solution for different tasks. For instance, we also work on the analysis of their entire program schedules or catalogs, and we even help audience measurement companies to analyze the performance of their programs. For instance, to analyze the repetition of individual songs or use distribution, and do similar work with analyzing of the advertisements.
So this really helps them make better business decisions, and probably much more quickly than doing it the manual way, and helping them also drive new creative and business possibilities, no?
Yeah, sure. Our technologies are designed to give broadcasters an edge over their competition at the moment where competition for viewers is just incredibly strong. The reality is that most companies with big archives cannot manually locate the content what they need with any degree of speed.
And that doesn't scale, does it?
No, no. So you cannot really, find a needle in a haystack, especially if you don't have right tools. And the big picture is that when working with the content in an archive, you need to be able to retrieve information by making it searchable. In this way, we help our customers improve their archive management processes and optimize their businesses. And we do all this through careful analysis and delivering the components that are just right for the job. And this helps them work in a way that is automated and highly accurate at scale, using that multimodal approach, which is the strength of Fraunhofer IDMT.
That's wonderful. Hanna Lukashevich, thank you so much for talking with me today.
Thank you, Janet.